Hey y'all, today we're going to talk more about polygons, and in this case we're going to talk about special polygons that we call regular polygons. So regular polygons are probably the polygons we're used to seeing. They're the ones that kind of look really nice, and they look that way because all of the sides are congruent, which means they're all the same length, and all the angles are congruent, which means they're all the same measure, degree measure. So I've taken this regular hexagon, it's got 6 sides, and I've shown you that all sides are congruent. So if I've measured them, they'd be the same length. And all of these angles are congruent, so if I took a protractor and measured them, they'd all have the same degree measure. So if I know that all the sides and all the angles of a polygon are congruent, I know that it's a regular polygon. And then I can find some things out about the angles in particular. One thing I can find out is how much one of the interior angles measures. We found the sum of the interior angles in the last lesson, and that was for any polygon, whether it was a regular polygon or it was a polygon that wasn't regular, meaning all the sides and all the angles wouldn't be the same. And then if we know that all the angles are the same, then we can find one of them. So we would take the sum of the interior angles and we would divide it by n, the number of sides, or in this case the number of angles. And that looks like this. We've got the 180 times n minus 2, and if we want to know one of the angles, because we know it's a regular polygon, then we can just divide by n, the number of sides. So I've done this example here. I have a regular pentagon. It's got 5 sides. If I want to know how big this one interior angle is, I can use my formula. I can plug 5 in for n, because that's the number of sides and angles I have. And I can simplify and find out that in any regular pentagon, one of the inside angles is going to be 108 degrees. So let's try an example. I have a heptagon, a regular heptagon. That means I have a 7-sided polygon. All the sides and angles are equal, and I want to find one interior angle. So I write the formula every time, just like when we ever use the distance formula or the midpoint formula, we're going to write it every time. Plug in 7 for n in both spots, and then we can just simplify. And for this one, we're going to have to do just a little bit of rounding, so I rounded to the nearest hundredth, and I found that in a regular 7-sided polygon, a heptagon, that one inside angle, one interior angle is 128.57 degrees. So if I have, there's my regular heptagon, one of these angles is 128.57 degrees. We can do the same thing for a dodecagon. That's a polygon with 12 sides. I want to know the angle measure of one interior angle of a regular dodecagon. So I write the formula every time. I can plug in 12 for n in both spots, the top and the bottom there, and then I can simplify. And I can get that one interior angle measure of a regular dodecagon is 150 degrees. So there's my regular dodecagon, and one of these interior angles measures 150 degrees. So pause right here. I want you to do the same thing, but this time for a decagon. So as always, write the formula. You should write it for every example. That'll help you remember it. A decagon has 10 sides, so I'll plug in 10 for n in both spots. And then all I need to do is simplify. So in a regular decagon, a regular 10-sided polygon that looks like this, each of these interior angles, no matter which one I measure, it should be 144 degrees. If I add up all the interior angles, it's 1,440. But one of them is 144 degrees. So we can do the same thing for the exterior angles. In a regular polygon, all of the exterior angles add up to 360, and they are all exactly the same as each other. So all I need to do to find one exterior angle of a regular polygon is take 360 and divide it by the number of sides or the number of angles. So here I have a triangle. I've drawn my exterior angle at this vertex, and I showed you the little green arc there. That's the angle I'm talking about. So if I want to know how big that angle is, if this is a regular triangle, I just do 360 divided by 3, and I find out that that angle is 120 degrees. What's kind of nice is that if you know this exterior angle is 120 degrees, it's easy to find the interior angle without even doing the one interior angle formula, because these two make a linear pair. So that means they add to 180. So this one exterior angle is 120. If I subtract that from 180, I can find out that this interior angle is 60 degrees. So if I know one, either the interior angle or the exterior angle of a regular polygon, I can find the other because I know they're linear pairs.
I'm going to put down there now.
So we have found a measure of one exterior angle of a heptagon. So we found the interior angle, so let's find an exterior angle. So we write the formula. We're going to plug 7 in for n, and we just got to do one thing, and that is divide 360 by 7. So again, I'll show you our heptagon, and if I quickly draw my exterior angle, that's going to be 51.3 or 51.43, and then it's supplementary because it's a linear pair with the interior angle that we found earlier. So we'll do the same thing for a dodecagon. So if you already know the interior angle, we could subtract it from 180, or we can use this formula that I'll write every time I use it. I'll plug in 12. And I'll get that one exterior angle is 30. So I know we found before that the interior angle was 150. So I'll draw my dodecagon. I'll get my exterior angle. So this exterior angle is 30, and we found earlier that the interior angle was 150, and they make a linear pair. They add up to 180. So pause here and try this one. So again, we'll write the formula. We're going to plug in 10 because we're finding a decagon, an exterior angle of a regular decagon, and we'll get that it is 36. And before, when we found the exterior angle of a regular, or the interior angle of a regular decagon, we found it to be 144, and that's because, again, they form a linear pair, so the interior and exterior angles are supplementary. So we're going to do 2 U-dos. I want you to find out the interior angle, one interior angle of a regular quadrilateral, and one exterior angle of a regular quadrilateral.